Photons. Until now you have thought of light as being a wave. Some observations are best explained by considering light to be made up of particles called photons. A photon is a packet or quantum of energy of electromagnetic radiation. We know that the higher frequency end of the electromagnetic spectrum, the gamma rays, have the highest energy, and the lower frequency radio waves have less energy. The energy of a photon is found to be directly proportional to its frequency, which we can write like this. The constant of proportionality is a tiny number known as the Planck constant. This is given the symbol lowercase h. So we can write that E equals hf, or the photon energy, is equal to the Planck constant multiplied by the frequency of the photon. The Planck constant has a value of 6.63 times 10 to the minus 34 joule seconds. I've copied this equation across to this slide for reference. As frequency is equal to wave speed divided by wavelength, we can also substitute in for the frequency here and write that the energy of the photon is equal to hc over lambda. Let's look at an example. Calculate the energy of a gamma photon of frequency 2.5 times 10 to the 20 Hz. Well, for this we will use this equation as we're given the frequency, so we can write down the equation. Then adding in the numbers, we have Planck's constant multiplied by the frequency, giving a photon energy of 1.7 times 10 to the minus 13 joules. Next, calculate the energy of a microwave photon of wavelength 12 centimeters. In this case, we can use this equation and write E equals hc over lambda. Putting in the numbers, we have Planck's constant multiplied by the speed of light in a vacuum divided by the wavelength, remembering of course to convert it into meters. This gives a photon energy of just 1.7 times 10 to the minus 24 joules, much smaller than the energy of the gamma photon we found here.